Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept of Simulink and how to use Simulink in actual field. In this particular video, we will be looking into the two aspects of Simulink which we usually see while designing any Simulink model. So as you can see on the screen, you have a system. Either you can have a rocket design, or suppose you want to create a rocket related model, or suppose you want to create a vehicle related model. Both of the systems that you usually see is a physical system. To model those system, you can follow basically two approaches. So the first approach is designing everything in a mathematical expression. So suppose if you give some thrust as an input to the rocket, then the acceleration could be an output from the rocket, which is vertically upward. The same can be expressed in the form of some mathematical equation, which we can develop by observing the system. So in this case, which is the system under observation, is the rocket system. Here you need to use mathematical expressions. So basically all the mathematical equations which you usually see in the textbooks. So those things you can apply in this particular type of modeling. And also for the same, you need to have a solid background of the understanding of the system. So if you do not have a solid understanding of the actual concept related which you want to build, it is very difficult to develop a mathematical model, because mathematical models are more detailed compared to any other type of modeling. So if you understand the system, how it is behaving based on your input, and how the system is responding based on your input, then only you can apply your concept to build some mathematical model. And for developing the mathematical model, the actual system should have some mathematical relationship between the input and the output that you are giving. If there is no relationship between in whatever the system that you are developing, the concept that you are applying should be valid in your system. It should be representing the behavior of the system. If it is not representing the behavior of the system, then there is no point of doing the mathematical modeling. And those expressions which you will be using should be applicable to the system that you are currently developing. So in this case, suppose if you give the thrust, then the amount of thrust is proportional to the amount of vertical acceleration that you are generating. So it is mathematically related. So that is how you can develop the mathematical model. If it is not existing, then you cannot develop it. Next is the signals that you will be using in mathematical modeling mostly will be Simulink signals, and those signals are mostly unidirectional. If you see, the signal travel from one direction to another direction, like one state to another state, and it is unidirectional. It will be flowing in this direction only. It will not flow in both the direction. If you see this signal here, also you will be able to see that there is a directional arrow that is representing the signal, how this signal flow is happening. So usually in Simulink, it flows from left to right. You will be able to see these arrows, and those type of mathematical modeling mostly use Simulink models. Coming to the next system, which is the physical modeling. In case of physical modeling, you will not have you will not need to use the Simulink blocks. You can use physical components. So this is an example of a gear differential and gear system. So this is a simple gear block, and this is a differential block. So this is more related to automobile transmission system. And here you are able to see we are using these components directly and connecting them. So here you can use the physical components directly, like this one. And also here how the gear system need to be designed in detail, or how the differential need to be designed in detail, need not to be known for the system design engineer who is developing this, because these blocks are predefined inside Simulink, and you can use it directly, and you can set some parameters, and with that parameter you can develop the model. And here the main thing is that even if you have very less understanding or about the concept, even if you know the concept on the top level or an overview level, you can develop the model. So that is how this physical system is more physical design or physical modeling is more taking part when some domain expert is not doing the design, but some newcomer is doing the design. So he can also do create the models. And if you see, there is no directions present in this type of signal connection. So this is one physical block, and this is another physical block. And if we are connecting these two, then there is no directional propagation of the signals, because these signals are interactive and they can act, they can behave like a real system. So here these signals are bidirectional, and it will behave like an actual physical signal. Like if you are pushing some block, then for example the block also exerts some reaction force on your body, so that you can feel it. So such type of things will be there in physical modeling. And yeah, so the different type of solvers that we will be discussing in this particular series will be used for like for physical systems, you will be using a different kind of solver, and for mathematical modeling, you will be using a different kind of solvers. Those things we will be discussing further detail in this particular tutorial series. So first we will start with the mathematical design, so mathematical modeling. And then post to that, we will be also doing some physical modeling, so that you will have idea on both mathematical modeling, plus you will also have idea on physical modeling. We also have a state flow tutorial series which is there in this channel. In case you also want to check like how logical graphical design happens in MATLAB, you can also check that series. That will be a good series if you want to follow. We will be looking into the mathematical modeling from next video onwards. Happy learning MATLAB and stay connected. In case you have any comment or query, please share it in the comment box. We can go through your comments. And so happy learning MATLAB. Stay connected. Thank you.